This is a web application that I wrote to calculate N for the Seager equation, detecting signatures of life on exoplanets. Dr. Sarah Seager is professor of planetary science and physics at MIT. This calculation only calculates the possibility of life, not intelligent life, but life on exoplanets. If you'd like to read more about the Seager equation, do a search on Google for Seager equation Wikipedia, and this is what you'll get. Let's go ahead and plug some numbers into the Seager equation. The number of stars observed. In the future, we're going to have space-based telescopes that will observe atmospheres surrounding exoplanets, and we're going to say that the number of stars observed will be 500,000. The fraction of those stars that are quiet, that means that stars that are not overly active with coronal mass ejections, and let's say that half of the stars that are observed are quiet. The fraction of stars with rocky planets in the habitable zone. Let's say that 1 in 5 stars, or a little bit over 1 in 5 stars, have rocky planets in the habitable zone. And the fraction of those planets that can be observed. Let's say that a tenth, 1 in 10 of those planets can be observed. And the fraction that have life, let's say 1 in 10 of those planets will have life. And the fraction of those planets on which life produces detectable signature gas, such as oxygen. Given enough time, I believe the atmospheres will be full of oxygen if they have life. Let's say that that's 0.99. And let's click for the answer to the Seager equation. Hopefully we'll detect 545 planets that produce detectable signature gas such as oxygen, and the average distance to such a planet will be 1,059 light years. Here we can see some candidate stars that are within 300 light years of 1,059 light years. This is not a complete list by any means. Here's an interesting star, Kepler-62. Let's have a look at the planetary orbits around Kepler-62. Kepler-62 is 1,200 light years away. The planets orbit a K2V star, which is a little bit smaller than our Sun. It's on the main sequence, and the approximate age is 7 billion years. You can see some nice circular orbits here, Kepler-62f, completely in the habitable zone. And there's another planet, Kepler-62e, also in the habitable zone, a little bit closer to the star. And there are some other planets orbiting in this system much closer to the star. This image was taken from NASA Eyes on Exoplanets. It's a very good program. Here's the URL for it. I'll include that in the credits at the end of this video. And you can check out the orbits of Kepler-62 in action. Kepler-62f is a planet larger than our Earth. Here it is here. We don't know if it's going to be a rocky world, a water world, or an ice world. There's no way of telling. But we would like to actually have a look at that planet to see if oxygen is a signature gas, and that is the Seager equation. Be sure to subscribe to the Floreshime channel, and I thank you very much. Bye-bye.